The Voyager 1 probe is the ship that is furthest from Earth, more than 24 billion kilometers in the middle of interstellar space. In this unknown territory, the probe is sending us a series of messages that have us baffled. It has been speculated in many media that Voyager has encountered an unknown force, even that they have hidden information from the public. It is true that something strange is happening with the probe that we did not expect. What I'm going to tell you is much more exciting and important to us than we initially thought. Voyager Waves 1 and 2 were designed to reach Jupiter and Saturn, taking advantage of a rare alignment of the planets in 1977. A mission that was going to last 5 years and is already half a century old. How is it possible? Some excited engineers thought these waves could reach interstellar space, but designers were warned not to worry about reaching interstellar space and to concentrate on observing Jupiter and Saturn. What happened is that they ignored those instructions and basically did what they wanted without going beyond the allocated budget of $250 million at the time. And they built not one, but two, in case one of the two failed. Apparently they succeeded. There is no doubt that those were different times. The Voyager program became a cornerstone of NASA, and they built the two waves in the 70s, with state-of-the-art instruments and the most advanced computers of the time. One of its curiosities is that each one carries a gold record, which is like a cosmic letter of introduction to future extraterrestrial beings, with sounds and images of the Earth in 55 languages, our position and how we are. Carl Sagan chaired a committee of scientists and engineers in charge of its design. Jimmy Carter, President of the United States, said at the time, "This is a gift from a small world, a world far away. We leave you a sample of our science, images, thoughts and feelings. We are trying to survive our time so we can live in yours." Thus the two 722 kilograms probes, loaded with fuel, left Earth in 1977, heading towards the unknown. Initially the two twin waves were supposed to visit Jupiter and Saturn, but they worked so well that their mission was extended to Uranus and Neptune. The success of the probes lies in taking advantage of a rare alignment of the planets that only occurs every 175 years. In this way, the waves fly over the giant planets, taking advantage of their gravity and propelling themselves. In the solar system, any probe must navigate in a circle like any other planet, and as we move away from the solar system we lose speed due to the attraction of the Sun. So one way to recover it is through gravitational assistance, taking advantage of the gravity of the planets. Here we see the trajectory of both probes with different objectives. It is like a billiard carom. To give you an idea of the enormous success that these two probes have had, they not only photographed the planets and measured their atmospheres, but they also observed the satellites of the gas giants for the first time, providing tens of thousands of photographs. We first saw geysers on the moon Triton. The volcanic activity of the satellite Io revealed unprecedented details of Saturn's storms, Jupiter's enormous magnetic field, Uranus with its tilted axis, and the strong winds of Neptune. The big surprise was Titan, with a dense nitrogen atmosphere like the Earth. Altogether, the Voyager mission discovered 22 new moons. It was the first time we detected oceans under the ice crust on other worlds. Once it reached Neptune with its great black spot, Voyager 2 continued its indefinite trajectory towards interstellar space. From Saturn, Voyager 1 reached 21.4 kilometers per second. That speed was enough to free itself from the attraction of the Sun and in the future leave the solar system. Now it is the probe that has reached the furthest, almost 23 light hours from our star. The speed was reduced as it left Saturn and attracted by the Sun's gravity, until it maintained a constant speed of 17 kilometers per second. From this distance, the Sun's gravity no longer has the strength to hold it. Beyond Neptune, we enter an unknown region. We discover that the environment of the Sun and the solar wind delimits a region called heliosphere, with a radius greater than 100 astronomical units. This wind is full of charged particles such as protons. When it meets the interstellar medium full of hydrogen and helium, it forms a protected oval-shaped region. These are just some of the incredible discoveries of the Voyager program, which has made the two probes the most successful in history. I'm sure some have wondered, how is it possible for such old probes to last so long and continue transmitting data? Because they have built-in plutonium batteries, Radioisotope thermoelectric generators. They are gadgets that typically contain plutonium-238. This radioactive element, by emitting radiation, is continuously heating up. That heat is used to generate electricity, and the ship's components are heated using a device called a thermocouple. Has an estimated life of 87.7 years. The large amount of data sent suggests a brutal amount of storage. None of that. The Voyagers have 3 computers that execute 11,000 instructions per second with 69 KB of memory and magnetic tapes with a capacity of 67 megabytes that send data to Earth continuously to avoid saturation and being overwritten again and again. The Voyagers have 200,000 times less capacity than any smartphone today, but those were other times when every last screw was used. However, nothing lasts forever. The waves consume about 470 W of energy to maintain all their instruments, but the generator provides less and less energy. So the solution was to enter saving mode and turn off the instruments that were not needed, such as the cameras, the infrared spectrometer, and others that were used for planetary inspection, leaving only the cosmic ray, charged particle, and plasma sensors. But before turning off its eyes forever, the probe took one last photograph of our planet, at the express request of Carl Sagan, more than 6 billion kilometers from Earth, in 1990, which it called the pale blue point. The light bands are due to the dispersion of the sun's rays. Once the image was relayed back to Earth, Voyager's cameras would never be turned on again. This has led to its consumption being reduced to less than 20 W, less than some current light bulbs. The waves are a reflection of an emerging technological society of the 70s. They continued with their hardware, crossing the vast regions of space. But on Earth we continued to progress in technology, and that is where the problems began. In recent years the failures have been increasing, and this is evident, considering that they are at least almost half a century old. Nowadays, any computer doesn't last more than a few years. In 2022, Voyager 1 had an error in its systems that prevented it from orienting itself and sent confusing data. Engineers had to update with patches to extend the mission and orient the antenna always facing the ground. There is an obvious degradation of the systems. Over time, some of the airwave systems have experienced degradation due to prolonged exposure to cosmic radiation and continuous operation for decades, affecting components such as batteries, scientific instruments, and communication systems. In addition, the power reduction gradually decreases as the plutonium-238 isotopes used in the RTGs decay over time. Every year that passes, the Voyagers have 4 W less power. Several software errors have occurred on Voyager over the years, causing temporary problems in airwave operations. On several occasions they had to ask for help from retired technicians who designed it and consult manuals from 1977. The original spacecraft control and analysis software was written in the Fortran 5 programming language, then with new updates it was ported to Fortran 77. Although some parts of the software are still in Fortran, others have been ported to AC. The ships communicate with the Earth in binary code of zeros and ones. 1 represents on and 0 represents off. These codes can represent various text characters and images. For example, this binary number represents the decimal number 21. On the other hand, each binary data can represent the pixels of a given image, if we know the source and its format. That information must be decoded to obtain the information we need. Another problem is intermittent communications. Due to the great distance between Earth and the Voyager probes, communications can be intermittent or subject to interference. Sometimes the waves can have difficulties transmitting data to Earth or receiving commands from here. Considering that each time we send a command it takes 22.5 hours to reach the probe, and it takes at least 46 hours to know if that command worked. The controversy has arisen when Voyager 1 has begun to send strange data, because it had encountered an unknown force, and this is where the intriguing thing that many media have commented on comes. Yes, it is true that Voyager has crossed an energy wall, but they did so in 2012 and 2018 respectively. In some cases it has been called a wall of fire, which is the termination shock. It is like a barrier where the heliosphere and the interstellar medium meet with temperatures in some areas of almost 50,000 degrees Celsius. However, the density of the interstellar medium is so low that Voyager did not affect them in the least. Knowing this medium is very important for us, not only to know more about the nature of our star system and the behavior of radiation, but also for future explorers who can go through the termination shock as ancient navigators subjected to the celestial tides. This energy barrier has nothing to do with the intelligible data that Voyager 1 sends us. The problem has been a strange data sending error in one of the three main computers, specifically the FDS Flight Data System computer, designed to collect information from scientific instruments, as well as engineering data on their status. Since the end of 2023, the ship has been sending repetitive sequences of zeros and ones, and now it has crashed. The solution when this has happened has always been to restart it or update it through patches. But this time nothing works, although it has been restarted again and again once sending instructions, keeps sending absurd data. According to NASA, the FDS does not communicate properly with one of its subsystems, called the Telemetry Modulation Unit. This means that at the moment we do not have scientific data of any kind. Fortunately, Voyager 2 continues to work with its patches and updates, but everything indicates that sooner or later it will suffer the same problem as its sister, and here I am going to tell you something important that has led to confusion in many media, that Voyager 1 had found alien life and that code was the key. Space is really so enormous that it is practically impossible to find life of any kind. In fact, the Voyagers are like drifting ships that have not left the solar system. If they wanted to leave, they would have to cross the Oort cloud in about 17,700 years. The Voyagers move at such a slow speed that in their trajectory we do not believe they will pass any habitable planet. They will continue to be trapped by the celestial tides of the Milky Way, sailing in the same plane as the Sun. They may come within 1.6 light-years of the star Gliese 445 in about 40,000 years, and within 1.7 light-years of Ross 248, by which time there may be nothing left of humanity. Voyagers have been our flagship with incredible achievements for half a century, and we are trying to recover our Voyager 1. Susan Dott, director of the Voyager missions, thinks it would be a miracle if we managed to recover it. We will try by all means to reprogram and configure it, but there is no doubt that our Voyager can't take it anymore. Has given everything it could for 47 years. This shows how primitive we still are, but also how much we can do with few means. Now with all this technology at our disposal, we can do much more for humanity. What are we waiting for? We have barely begun our space explorations. Many more discoveries await us, and this is the beginning of our great journey. Hush.